Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And in this video, I want to explain example 13 of Pure Mathematics 2, topic number 3, Exponential and Logarithms. And we are being told that you can solve more complicated equations by taking logs. Taking logs on both sides. Taking logs on both sides. That is exactly what we need to understand today. Taking logs on both sides. It's more or less like what I have introduced in the previous examples as alternative, because this log, when we take logs on both sides, it will automatically be log to base 10. And moving forward, we shall be able to see it. And let's see, we are told that whenever fx is equals to gx, a function of x, or is equals to a function of another x, then it is important to know that when the left hand side is equals to the right hand side, whatever should happen on the left should happen on the right, and both sides will remain equal. It follows that the log to base a of fx, a function of x, is exactly equals to the log to base a of the function of x, again gx. Having said that, let us look at example 13 and say, find the solution to the equation. In other words, find x in 3 raised to power x is equals 2 raised to power x plus 1, giving your answer to 4 decimal places. And that is just like it. So we are faced with 3x is equals to 2 raised to power x plus 1. And this is now when we say introducing logs on both sides. We have log, this has to be to base 10, but we don't need to write it, of 3 raised to power x is equals to log of 2 raised to power x plus 1. But because we are beginning to solve this kind of questions, let me just indicate base 10 and base 10 so that 3 does not appear to you like the base. Now, when we apply the index laws of logarithm, this one gives us x log to base 10 of 3, because the index becomes a coefficient, is equals to x plus 1 log to base 10 of 2. And at that particular point, it is important to say something. It is important to say something because we can already see it could be possible to rewrite this in a different way. This one becomes x log to base 10 of 3 equals to x log to base 10 of 2 plus 1, which is this one, times log to base 10 of 2. And let me just explain how that one gets to be. Because it would have been possible to write 2 raised to power x plus 1 would have been 2 raised to power x times 2 raised to power 1. So the moment we are talking about the log into base 10 of 2 raised to power x times 2 raised to power 1, it would have been possible to log and look this looks like something that can be done. And at that point, if we wish to introduce the logarithm when we have two numbers which are being multiplied, we could talk about log to base 10 of 2 raised to power x plus log to base 10 of 2. Just because we said log to base whatever a of ab is equals to log to base a of a plus log to base a of b. That one should not be forgotten. Plus log to base a of b, the same base. So at this particular point, it follows that even if I could probably re-explain this from 3 raised to power x is equals 2 raised to power x plus 1. The law of index dictates that 3 raised to power x. The law of indices dictates that is equals 3 raised to power x is equals to 2 raised to power x times 2 raised to power 1. And it goes without saying this is going to be 3 raised to power x is equals to 2 multiplied by 2 raised to power x. And introducing the logs here, this is what we are saying. Log to base 10 of 3 raised to power x is equals to log to base 10 of 2 raised to power x. That way, you can see now these two are being multiplied, which gives us log to base x log to base 10 of 3 is equals to log to base 10 of 2 times log to base 10 of 2 raised to power x. Now this one will be affected by the index law, and this is what now brings this one. So we rewrite it afresh, having now understood that x log to base of this one, x becomes a coefficient, x log to base 10 of 2 plus log to base 10 of 2. That is where we were. And of course, it goes without saying that because we are looking for x, we will have to bring all the x terms across. So x log to base 10 of 3 minus x log to base 10 of 2 is equals to log to base 10 of 2. And when we realize that x is a common factor here, it becomes x open bracket log to base 10 of 3 minus log to base 10 of 2 close bracket is equals to log to base 10 of 2. What does this really mean? This means according to the law of indices, we have this one to be divided x log to base 3 over 2 is equals to log to base 10 of 2. And if we divide by both sides by log to base 10 of 3 over 2, log to base 10 of 3 over 2, this one cancels out, and of course now x becomes log to base 10 over 2 divided by log to base 10 of 1.5, log to base 10 of 2 all over log to base 10 of 1.5. And this is now the calculator work, and it goes without saying logarithm of log 2 divided by log 1.5, which is easily log to base 2, 3 over 2 is 1.5 of course, log to base 2, you find that, divide by log to base 1.5, close that, you get 1.70. This is 1.7095. Of course, to 4 decimal places. 1.7095. Yes, it's a long one, but of course, we need to. It's not long, but we have just I've just thought I need to explain deeper what was happening, and that is it. So please, ladies and gentlemen, follow, subscribe, and let us work together. All right.